2013 and 12.
No, anyway, she was no. The instructions to me over because she drops me off. She's like, I don't find it safe because cars are coming to walk in to get to the lockers. This truck is coming toward them, and they're not being.
Check A, check.
Silence yourselves.
Okay. Sorry about the late start. I had a lot of problems with the computer getting it to work.
Yeah.
So. Okay, so I kind of want to work. Oh, and I opened up the wrong application just now. Yeah, stupid Microsoft. Just kidding, Bill Gates. I love you.
Don't hurt me.
I know, that's going to be on the internet. He's going to hear me. Yeah.
You know, Bill Gates has donated more than half of his totals.
It's amazing. It's a lot of money.
Yeah, I swear.
Yeah.
He does a lot of charities. Yeah.
As of right now, he has like 50, 60 something. No, it was 60.
He's just extremely rich. He donated a lot. He's
donated over $30 billion to charity. You guys heard like when those just give it to me. That's how much it's time to pick it up. He makes more than $100.
I have a problem with cause.
Yeah. If he drops $100 bill,
I've not heard that.
Did Miss Herman ever like collect the bills?
She checked it yesterday.
Okay.
Check it, but
You had to go again. Like,
Does anyone know when the national parks are closed still? Because of the government.
yeah.
pretty good.
No?
Probably go to high beat.
Yeah, I'm gonna take my
Go
dog.
to the
I
national
got
park.
multiple choice. It was easy for me.
When are they closed till?
They're closed until they pass a. They're closed until they pass a budget.
Wait, who's closed?
Until then, they're closed until we have the government.
It's literally Rover's like
Okay. Let's take a look at this, everyone. Number one, we want to find the proportion of runners who finish in more than 70 minutes. So I'm going to draw the curve here. The mean of this curve is 61 from the information, which gives me a z-score of 0. And the standard deviation is 9 minutes. So I'll just find the steepest part, draw a line straight down. That's 9 minutes. So 61 plus 9 is 70. And we want to know, taking more than 70. So that sounds like we want the area to the right of 70. And this is one of those baby problems because the standard deviation is already given to you as one of the measurements. So you can just write down for number 1 that the probability that x is greater than 70 is going to be equal to the probability that z is greater than 1. And that's one of those curves that we're supposed to have memorized, and that is 16%. That's 16%.
Would you rather us write 16% or the actual number?
It's approximately 16%. If it's multiple choice, just pick whichever is closest to 16%.
Proportion, so doesn't that mean the decimal?
Oh, proportion, yes, you're right. So proportion is 0.00, no, 0.16. Approximately. So let's remember that in the normal distribution, and I know I saw this graphic up here somewhere. In a normal distribution, the middle, here we go. In a normal distribution, the middle, and this is a horrible graph actually, this is not where z equals 1 is, but the green section is 34%.
Actually, it's
The middle section
pretty bad.
Yeah, this is a really bad normal distribution.
It's almost like halfway there.
The the blue and the green together are supposed to be 95% approximately. And then the purple, blue, and green, all of this together, is approximately 99.7%. And that was that rule. And this was from the 68, 95, 99, 7 rule.
So, if we have questions like this, where the where it's a pretty, like, whole Z, where it's like a whole number Z score, like 1, 2, or 3, do you want us to give you the probability based on the rule or based on the calculator?
If you give it based on the rule, make sure you say approximately. And if you do it based on the calculator, then you could just paste it up to 4 decimals. Okay? So technically I should be writing 1600, but since it's assumed that any trailing numbers are zeros like calculus, it's fine. Okay? So that's one that should have been pretty basic. Did that feel basic? Great.
Are we going to have to do a lot of sketching?
Question 2. You only really need to sketch for multiple choice. For free response. I'm sorry.
So
Question.
we're not going to have random sketching like this, though?
No, only for multiple choice, or only for free response.
Okay.
Okay. We want to find the proportion of runners who finish in less than 63 minutes. Did I say 43 or was I? That was 43. Okay, so here we go again. We got 61 is the mean with a z-score of 0. We want to be to the left. So if I do 61 minus 9, that gives me 52. All right. So that means 43 should be right about here.
Yep. It's exactly true.
That's -1, and less than 43 would be this area here. So this is more than 43? Oh, I'm sorry.
Other side.
Wrong side. So more than 43.
What's the trick to making a good normal curve? Like to draw it?
Practice.
But what if I don't have time?
Do your best.
Yeah, that's really it. It's practice. So we want this curve right here. And so in terms of talk, then we need to convert that 43 into a z-score, because we can't calculate unless we have the z-score. So z is going to be equal to that 43 minus 61 over a standard deviation of 9. That gives me a z-score of -2, right? So now this problem becomes, what's the probability that z is greater than -2? And yeah, I think this one I am going to use the calculator. Too fast? Sorry.
If it's an even one, just say we can use the.
Yeah, you can use the rule. So I think it's going to be 97.5 approximately, using the rule.
95.
No.
Didn't you say it's 68, 95, 99?
Yeah, the middle is 95, but we're not looking at the middle here. We're looking greater.
Why is it, what was the
Well, basically, it's like that rule plus half of whatever's left over.
Okay, so let's see. We're going to be doing a normal CDF. Oh, man, this calculator looks really bad. On my graph, the lower is -2, right?
Yeah.
The z-score is -2. The upper is infinity, so let's do that. 1 E 99, 0 and 1. Make sure that's 0 and 1 if you're putting in z-scores. Put in paste. Where did I go wrong? Oh, obviously. -2. Yeah. So 9.9772. So this probability is equal to 0.9772. And of course, you could just go ahead and write it out approximately I knew it. Really?
Just prox period.
Approx period. So approximately 97.7% of runners finish with a time greater than 43 minutes. Proportion? Okay, so the proportion is 0.9772. Okay. 2. 3. Okay, the plot shown is a normal probability plot. The data plotted on the x-axis and standardized value on the y-axis. That's the way we do it in class. Which statement is true? And I think maybe we should take a look at a few things here about this generally. Let's do a, if we have a normal probability plot that looks kind of linear like this, okay? You should know that this line is the mean. That represents where the mean is. So this is the mean score right there. So 3 normal probability plots. Normal probability plots. So you can kind of tell that this is symmetric and it's linear, so it's approximately normal. Contrast that with what it would look like if we have something like this. Wait, what just happened there?
Wait, that doesn't look good.
That's approximately linear. What if I had one like this? Here's my graph. There's my mean, and then it starts to do one of these things. And this is kind of what you have in your work. Notice that over here it's linear, and then it just kind of tails off on the right side. Okay, this is a right skewed distribution. That's what a right skew would look like on a normal probability plot. And we should do the same thing with a normal probability plot for a left skew. So a left skew would look like this. A few dots here, and then it gets like that. So that would be a left skew. Again, you notice that these values are very far away from the mean. These values are kind of closer to the mean. That's the way a left skew. Based on that information, the question in 3 looks like it's a right skewed distribution. Okay. Question 4. We have a normal distribution, and it says that we have a mean of 68 and a standard deviation of 2.5. We haven't used this in a while, but remember this is the This is the abbreviation for a normal distribution. The mean is 68, standard deviation is 2.5. And we want to know half of the young men are shorter than. So in other words, we want the probability that x is less than this number, x1, is equal to 50.50. So what is x1?
68.
Well, if it's normally distributed, it'd be the mean. Half of the population is always less than the mean. Okay, so in a normal distribution, yeah. In an approximately normal distribution, half of the observations are below the mean and half are above the mean. This is all approximate, so it could be a little bit more, it could be a little bit less, but it should be right around half. Okay? 5. Mm-hmm.
Just because number 4 says approximately normal, then it's just half and half. That's just like the way I answer it.
Exactly.
Okay, so you
Exactly.
don't really do any more.
Mm-hmm. And now if you said approximately 68% or approximately 16, no. Yeah, approximately 16 are greater than what height? And that's a different problem altogether. So I guess let's just do that kind of extension-wise. So extension of the problem. Okay. What about approximately 16% of men are taller than what height? Okay. Same kind of question, a little bit more difficult. Let's draw that normal curve. Our mean was 68. That's a z-score of 0. And we want 16% greater. So let's draw the one standard deviation here. And that's a standard deviation of 1. 68 plus 2.5 is 70.5. Yeah, it tells us that the mean is 68. And as if by magic, or this area here just happens to be 16% by the 68, 95, 97, 99.7. So by the 68, 95, 99.7 rule, approximately 16% of observations are greater than a z-score of positive 1. So for my answer then, 16%, approximately 16% of males are taller than 70.5 inches.
If it was something like 22%, we would just plug it into the inverse norm.
Yeah, if it's anything else, you would have to inverse norm it.
How does it roll?
Okay. Sure. That good? Wow, I can't believe that worked. Oh, okay. Yeah. maybe it's a good idea that we do this, that we go through the 68, 99, 95, 99, 7 rule, just to make sure that we all have that. Let's, because it really will help give you a lot of shortcut. So the 68, 95, 99, 7 rule. So I'm going to just go ahead and paste that one. Okay. And we're going to look in between one standard deviation. So if this is a standard deviation of 1, and this is a negative 1, and this is a standard deviation of positive 1, okay, then this area here is all 68%. Okay. But because you know it's 68% and it's symmetric, you can actually break this down even better. You can break this down into 34 and 34. Okay. And if this is 34, then the remainder over here has got to be 16. And if this is 34, then the remainder here has also got to be 16. Okay. So knowing that that middle is 68% actually gives you a lot of information beyond just that 68. Let's look at 95. Okay. So 95 is 2 standard deviations. So there's a negative 2 and there's a positive 2. And 95 divided by 2 is 47.5. So just like the 68 rule, this tells us a lot more than just 95. This tells us that if I'm between 0 and negative 2, I got 0.475. And if I'm between 0 and positive 2, I got 0.475. Again, everything below the mean is 50%. So that's 2.5, right? 0.025. And this is also 0.025. So just like the 68 part of the rule, the 95 part of the rule gives us a lot more information than just 95%. And then let's take a look at the last one. The last one is z-score of negative 3. Let's label that 0 again. And let's just pretend that that's negative 3. That's not actually where negative 3 is. Okay, and in this one, the middle is 99.7, thank you. And this looks like pea soup. Or vomit, one of the two.
Or chartreuse.
Is chartreuse really a pea green?
No, it's like a pea soup green.
Is it really?
Yeah, it's like a dark, deep.
I hope you don't mind, I'm going to defer to the females in the audience. Is that what a chartreuse is, like a green?
Yeah, it's a dark green.
How am I supposed to know?
It's like if you were to mix asphalt syrup with that color, that's a chartreuse. Look up chartreuse.
What is it?
How do you spell it?
I always thought it was a really dark green.
No, it's a really dark green.
What is dark green? I didn't use coffee.
I have no idea.
4985.
985? 4985, okay. So we got 0.4985, and that's 99.7 divided by 2. 0.4985. That means that must be 0.0015. And that right there is also 0015. Okay. If you only remember one standard deviation, that's going to really help you out a lot. If you can memorize all 3 of them, or at least remember how you can get all the information, then you're going to you've got a lot of good stuff in there. Boy, I sound like I'm crazy. Do I sound crazy? A little bit. Yeah, Sarah, and then John.
So how does this really help you? Like when you look at a problem, how does this really help you?
Well,
How do you use the rule?
for example, like if you standardize something, say the problem is, bigger, we want to know what percent are greater than 92. We standardize and we find out that 92 happens to be a z-score of 3. Okay, so we want to know what area is greater than a z-score of 3. Then using this rule, you can just kind of get 0015. Okay? Or let's say we want to know we want to know between 40 and 50. And we find out that 40 and 50 have a z-score of -2 and +2. So what area is between a z-score of -2 and +2?
Oh, never mind. Yeah.
It's 95, right?
Yeah.
Yeah.
Okay.
Okay. So you have to standardize first.
Thank you.
Yeah.
So if it's standardized and between -1 and 1 standard deviation, 68%, that means all of these are, then that means 2 standard deviations has to be 95, and then 3 standard deviations has to be 97.
Yeah. As long as we say approximately normal, all of those proportions have to be true.
Okay. That's approximately normal for any distribution. Okay.
And I think we left off on 5.
Yeah.
5. Okay. But this is great. 5. This leads us nicely. So question 5, we want to know 5% are outside of which range? All right. So that sounds to me like we're saying we have a normal curve. Oh, that's pretty good.
Which one's 5%?
And 5% is on the outside. Okay, so in other words, these two on the outside are 5% together. Okay, so outside is 5%, and that means the inside is 95%. That's part of the 90. That's part of the 68, 95, 90, 97. So this has to be a z-score of 2.
But how do you know it's like not skewed? I guess not.
So this is
Yeah, they're telling you it's approximately normal. So they're telling us that -2 is equal to some number minus the mean of 68 divided by 2.5. And they're also telling us that +2 is equal to the other one minus 68 over 2.5. Now, you can go ahead and solve this if you want with the calculator and the solver, or you can just remember we're talking about a z-score of -2. We know what the mean is. The mean is 68. If one standard deviation is 2.5, 2 standard deviations, 2 times the standard deviation has to be equal to 5. So what we're talking about is 68 minus 5 and 68 plus 5. 68 minus 5 is 63. This is 73. So then that sounds like we're saying 5% of males fall outside the range 63 inches to 73 inches. Alex, what were you saying?
But isn't 5% of males fall outside the range? Isn't that already given by this stage? Why do you need to state everything if you have the information already?
I'm just summarizing the answer. That way, if someone goes and reads this, they'll know what I'm trying to say.
Is it still recording right now?
It's still recording, yeah.
Hey.
This is how you want us to answer.
if you're writing this down on a test, leave a sentence.
So
Be in
for
context.
our test, this, if this
Yeah.
one is, okay, just make sure.
Yeah, John.
Since it says heights outside the range, if you put outside the range of like a z-score with plus minus 2, that would be marked wrong.
Yeah, because I think the idea here is to get it in context of the question. 2 z-scores is technically correct, but it's not in context. Okay, so for number 6, I'd like you to remember that standard deviation is a measure of spread, or the average distance from the mean.
So C.
Okay. So when you're answering this question, you just got to ask yourself, am I increasing that average distance from the mean, or am I increasing the average distance from the mean? Okay. I'm adding stuff to the tails. I'm adding stuff to the outside. Okay, I don't know if this, no, that's ugly. Sorry.
It's okay.
Okay, so I'm adding stuff here. I'm adding stuff to the outsides. Is that going to increase or decrease the average distance from the mean?
Increase.
Remember, the mean is in the middle. So adding to the tails increases the average.
Hey, Rizwan.
Therefore, adding to the tails will increase Okay, so adding to our tails should increase our standard deviation.
Do you have to include that stream of information, or can you simply state adding to the tails will increase thing? Because that's choice.
Whichever will correctly convey.
Okay, but if that was an FRQ question.
You know, if you wrote all of this, no one would. If you wrote all of that,
No one would.
yeah, no problem. Okay, the area under a standard normal curve corresponding to an area between a z of -0.3 and less than 1.6. So let's draw our normal curve. Let's locate a z-score of 0. Let's locate a z-score of -0.3. That's approximate. Let's figure out a z-score of 1.6. That's about right here, let's say.
Why is it 0.3? It's 0.2.
It's 0.2?
Yeah.
Really? Mine says 0.3. Okay. Oh, I'm on last year's model, that's fine. Okay, so we want this area. We want the... So we need this area right here between -2 and +1.6. This is a calculator question. Calculator. Let's do this. Norm CDF. -0.2 to 1.6. Did I get that right, or did I flip it back again?
It's correct.
Good. Exactly the same. Oh, you will make it look like this. Norm CDF, like that.
If you were given a different, so under area under, if it wasn't a standard normal curve and it gave you a different mean and a different standard deviation, is that where you would change those the numbers within?
No.
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 You never change those.
I wouldn't. There's no reason to.
Okay. So that's only if given a different.
No.
Okay.
No.
Really?
Yeah, I wouldn't, because in this class you always have to figure out the z-score.
Okay.
So it
And
serves.
those change the z-score.
It serves. Yeah. It. Well,
What do those do exactly?
I don't want to.
Okay.
It just confuses.
don't mess with it.
Yeah. Just don't do it.
So if we were given a mean and a standard deviation, that wouldn't affect this problem.
Yeah, of course it would.
So then what do you do with it?
You'd have to normalize.
Oh, okay.
Okay. So what? 0.5244. So the probability, or the proportion, between negative 0.2 and 1.6 is equal to 0.5224 from the calculator, right?
We don't have to state that probability is equal to area.
No. Yeah.
He's like, who?
You guys are all very
Okay, I'm gonna take a short break to so we don't have gigantic hour-and-a-half long videos. So take a short break. This is gonna be a very short break.